Good afternoon. My name is Zoe Laskowski, and I work within ADEQ's Hazardous Waste Unit as a hazardous waste inspector. The topic of this presentation is hazardous waste generation and management in the automotive industry. Today we are going to identify and understand RCRA, learn how to identify hazardous wastes in the workplace, and learn the steps of proper hazardous waste management in order for you all to operate safe and compliant facilities. Properly managing hazardous waste provides benefits for all parties involved. Businesses may benefit financially through reduced product purchases, the avoidance of costly penalties, and an increased customer base. Additionally, you'll be ensuring safe working conditions for staff and a clean environment for everyone. The Resource Conservation and Recovery Act, known as RCRA, was enacted in 1976 by the EPA to set standards and regulations pertaining to the generation, management, and disposal of hazardous waste. Within RCRA regulations, hazardous waste is defined and 3 tiers of generator categories are identified. The generator category of your business determines the regulations you're required to adhere to. All generators of hazardous waste are responsible for their waste from the moment it was generated throughout the disposal process. Also known as cradle-to-grave management responsibility, this means you are responsible for your waste even after it leaves your facility and is in transport or at a disposal facility. Identification of a waste as hazardous according to RCRA regulations can be thought of as a 4-step process. First, the material must be a solid waste. The applicability of the term solid waste does not apply based on physical structure, but rather whether the waste is abandoned, recycled, or inherently waste-like. If it is, then it's a solid waste. Next, the solid waste must not be specifically excluded from RCRA regulations. If the solid waste is not excluded from RCRA regulations, you must accurately determine if the waste is listed within RCRA regulations or if the waste possesses one of the 4 hazardous characteristics according to RCRA. RCRA regulations specifically identify some wastes known to be hazardous and classify them within 4 waste code categories, known as the F, K, P, and U lists. F-listed wastes are common within the automotive industry, specifically F code 001 through 005, which refer to waste solvents. P and U listed wastes are pure, unused commercial chemical products, some of which you may find from time to time within automotive repair practices. RCRA has also identified 4 characteristics which, when carried by a waste, qualify the waste to be managed as hazardous. Most commonly seen in the automotive world are ignitable wastes and toxic wastes. Any waste with a flash point below 140 degrees Fahrenheit is considered ignitable. Liquid wastes with a pH below 2 or above 12.5 are hazardous for corrosivity, while reactive wastes are generally unstable under normal conditions. Toxic wastes are listed as D code wastes within RCRA. It's important to note that a waste may be hazardous for toxicity, even if a D code waste is not the only constituent of the waste. Each toxic contaminant which carries a D code listing has a specific regulatory level, which indicates the amount of the contaminant within the waste which would qualify the waste as hazardous. 40 CFR 261.24b outlines the regulatory level of each D code waste. Common toxic wastes on the D code list, which you may see in your industry, include but are not limited to methyl ethyl ketone or MEK, chromium, and benzene. As you can see, toxic constituents have a different threshold for which its concentration within a waste would require the waste to be managed as hazardous. The 3 generator status categories are very small quantity generator, small quantity generator, and large quantity generator. Your business's category is defined by the amount of hazardous waste generated each month in weight, not how much waste is shipped off-site within a calendar month. There are different regulatory requirements for each generator status. Since businesses' generator status can change over time due to changes to process or production volume, generators are responsible for correctly and routinely evaluating their generator status and making any required changes to management standards for their facility as required of their generator status. Waste determinations can be made with safety data sheets and generator or process knowledge, and sometimes will require analytical testing. The 4 steps of a waste determination can be organized into a flowchart of questions. If at any point your answer directs you to not subject to RCRA, then your waste is not a hazardous waste. Safety data sheets are provided for all chemical products sold and are usually available online. You can normally call your product supplier if safety data sheets cannot be found online. And what you're looking at here are the covers of 2 safety data sheets for solvents used in painting processes. Safety data sheets will always look similar and have the same 16 sections. Section 3 will include ingredients such as metals or other toxic constituents, and Section 9 will list the material's physical and chemical properties. In Section 9, you can check to verify the material's pH for corrosivity, if applicable, and flash point for ignitability, that is below 140 degrees Fahrenheit. Here is Section 9 for a common solvent used in painting, and I would like to give you a minute to determine, based solely on the properties of this material, if it would be hazardous when a waste. What you should have found is the listed flash point of the product is less than 140 degrees. Specifically, it's 109 degrees Fahrenheit. This material, once a waste, would then be hazardous for an ignitability characteristic. Since it is also a solvent, generators should verify if any F codes apply as well. Here is Section 3 of a safety data sheet from a common industrial material used as a solvent and plastic welding agent. And I'd like to give everyone a moment to determine, based solely on the composition of this material, if it would be hazardous when a waste. So we know that methylethyl ketone, or MEK, is a toxic constituent, and we can see that it is the sole ingredient of this product. Therefore, generators using this product should be mindful that it would be nearly impossible for the spent material to be below the regulatory level for MEK, and then that waste would be toxic. Since MEK is also a solvent, generators should verify which F codes would also apply, and remember that a waste can carry multiple waste codes. Now that we've discussed how hazardous wastes are identified, let's look at common ways they can be generated and in which processes you are likely to see their generation. Expected waste fluids or byproducts, as well as unexpected spills, can generate hazardous waste. Expired chemicals and products no longer of use habitually accumulate in areas such as storage and maintenance rooms. Consider routine cleanouts of these areas to avoid large accumulation amounts like you see on the right here.